You'll be okay, I promise you.
I won't be.
You will.
I won't be.
Okay, so today we're going to talk some more about limits. Yesterday, or not yesterday, day before, when we talked about limits, we talked only about the general limit, which is if you're coming at a specific point on a graph from both sides. Today we're going to talk a little more about the general limit and some properties of those, but we'll also talk about right-hand limits and left-hand limits. So let's talk about right-hand limits and left-hand limits first. So let's say I have a function here that is super weird. So I'm just going to make up these numbers here. So this is 1, 2, 3, 1, 2, 3, 4. And our function goes up to here, approaching 1, and then it goes from here down to there, closed circle, up to there, closed circle, and then we'll do like an open circle here, down there. So that's what our function looks like. Is that better? Okay. So that's what our function looks like. So as we're, I already know, dude, stop. Okay, so let's take a look at what the limit, and I'm going to call this function g of x, and that encompasses the whole thing, all of the pieces. So let's say that g of x, or I'm looking for the limit of g of x as x approaches 1. So if I'm looking for just the general limit, as I'm going towards 1 on the right hand side, it's going towards 3. And as I'm going towards 1 on the left hand side, it's going towards positive 1. Since these two are going to two different numbers, then the limit of g of x as x approaches 1 is what? Does not exist, dne, okay? So in this case, the limit would not exist. Now, I can change that though, and I can look at the limit, and you don't have to change your assignment from Tuesday. If I look at the limit as x approaches 1, and then I put a plus sign on it, that means as x approaches 1 from the right-hand side of the equation, plus meaning to the right. So the limit as x approaches 1 from the right-hand side does exist, though.
3.
Right. And so in this case, g of x would be 3. And I can also change this to be the limit as x. Nobody's ever died from this.
It's one change.
Right. So I can also look at the limit as x approaches 1 from the left-hand side, which is the negative side, left being negative. So in that case, as it's approaching 1 from the left-hand side, what's the limit approaching? 1. So if these two numbers here, if the right-hand limit and the left-hand limit are different, then the general limit does not exist. And the general limit is what I taught you guys about on
Monday.
Tuesday? Monday?
Or on
Oh, that's right, on Monday. The general limit is what I taught you guys about on Monday. Now I'm just adding the right-hand side and the left-hand side limit. And there's one or two problems on your assignment where you will have to worry about left and right-hand side limits. It's not that big of a deal. I promise you no one's ever died from it. Not one person. All right, so the other thing that we're going to look at here is a few properties of limits. So I'm going to create two new functions down here. I'm going to call them, I don't know, let's go crazy and call one of them j of x. I know, it's nuts. And I'm going to call this other one over here k of x. No, it's super not a joke. It is not JK. No JK. Do you guys remember that commercial that was a long time ago where like the old lady was texting and somebody was like, "Who are you talking to?" And she was like, "IDK, my BFF Rose." That commercial comes in my head all the time. Yeah, it does. A place where yes. Okay. So my function jk, let's see, it's going to look like, or my j of x is going to go up to here, there, and then at 1 it's really here. And then from 1 to 2 it's going to go down like that. And then from 2 to 3 it's going to go up like that. And then my k of x function is going to go, so at 1 it's at 2. And then it's going to go at 2 it's at 3, and then at 3 it's at 2.
It's at 3 now.
This is supposed to be
I'm talking about J.
right. So this should be at 3. I just overshot my mark a little bit. I'm an imperfect person.
Aren't we all?
Yeah, I would hope so.
I thought you were a robot.
No, super not. Okay, so what we're going to look at here is some compound limits. So some limits that require either a composition of the functions or the two functions to interact in some way. So first, I'm going to look at the limit as x approaches 1 of j of x plus k of x. So this, I promise you, is not that bad. We're going to look at the two limits separately and then just add them. X approaches 1. We're going to look at the two limits separately and then just add them. So in this case, the limit of j of x as x approaches 1 is what? 2. Did you guys see that? Even though at 1 it's 3, but the limit as it approaches 1 is 2. And the limit of k of x as it approaches 1 is 2 as well, right? Which is 4. Okay, nobody's fainted yet. That's good. Let's take a look at the limit as x approaches 2 of j of x times k of x. Oh, I know. We just knocked it up. Wait until I have you compose the two functions. You just took a test on it?
Plug it into
So-
each other, Mike.
Oh, I didn't get on that.
Okay, so the limit as x approaches 2 of j of x, the limit is approaching 0. And as x approaches 2 for k of x is 3, so it'd be 0 times 3, which is 0. Okay? Yeah, sure. All right, so now Michael. Yeah, that's what I'm going to do next. So let's take a look at the limit, because that's part of your assignment today. The limit as x approaches 1 of, let's do k of x divided by j of x. So as we're approaching 1 for j of x, it's approaching 2. And as we approach 1 for k of x, it's approaching 2 as well. So 2 divided by 2 is 1. Kind of, sort of? All right. Now, the last one we're going to look at here is, let's look at the limit as x approaches 3 of k of j of x. I know. So we're going to put 3 into j of x first, and the limit as x approaches 3 for j of x is 2. And then we're looking for, right, and so the overall limit is 3. Kind of, sort of?
Simple.
Okay, cool. Let's take a look at our assignment then. There's a few specific problems I want to go over with y'all from the assignment, but other than that, it shouldn't be too bad. Like I said, we're splitting this section into 2 pieces. The back side is way darker than the front side, so sorry about that.
Ooh, I like it. Oh, I don't want that.
Let's take a look at.
Are we doing number 9?
Yeah. Okay. Oh, yeah. So what I'm assigning from this. Oh no, you don't have to do number 9. We'll talk about number 9 tomorrow in class. We'll do like a whole thing. So 1 through 8 for today. Tomorrow we'll talk about the Lorentz contraction formula. It's really cool. Okay, so for this though, we're looking at 1 through 8. That's what I'm assigning today. All right, so question number 1. Just kind of, I'll go through like maybe one piece of question number 1 with you guys, and then we'll talk about maybe, I don't know. Oh yeah, then we'll talk about question 3. So question number 1, the limit as x approaches 1 of f of x plus g of x. So the limit as x approaches 1 for f of x is 2. And the limit as x approaches 1 for g of x, let me fill this in here since that didn't copy super well, is 0. And so then if I add the two together, yeah. Okay. And then f of x times g of x would be 2 times 0 as x approaches 1.
0.
2 divided by 0.
No split.
Undefined. Yeah, it's undefined. Because you can't divide by 0. I've shown you guys why you can't divide by 0 before, right? Okay, do you remember why?
Something about hope.
Okay, yes, I did talk about the USS Yorktown. The USS Yorktown had to be put in dry dock for 3 weeks because somebody tried to divide by 0 on its main computer, and that broke it.
Broke the whole thing.
Yeah, yeah. The USS Yorktown was the first completely integrated battleship,
Pretty dang.
and on its shakedown cruise, somebody tried to make the main computer divide by 0, and it had to be hauled back to dry dock and put in dry dock for 3 weeks while they replaced big pieces of the main computer.
I'm sure that guy got fired.
Yeah, for now, just know that you can't divide by 0. And then f of x composed of g of x. So g of x.
So f of x is
How do you
0.
know this is 2 and 1?
So yeah, so you're gonna estimate this because you can't see exactly. The answer key says 1.5, but I put 1.25 on my answer key. I know it's super not 1.5. 1.5 is here. There.
It's like 1.3 or 1.
I know the answer key is wrong. I think it should be 1.25 or 1.3 or something like that. Okay.
How do you know this is 2 and 1?
Question number 2 uses the same graphs, so I'm not going to go through that with you. Question number 3 I will go through with you though.
Alright.
So question number 3, we've got this. It uses this figure down here, which does this. You're going to have to do some estimating for questions 3 and 4. All right. So first, it says the limit of h of 2x minus 2 as x approaches 2. Well, if you listen, if you substitute 2 in for x, this becomes 4 minus 2, which is 2. So we're looking for the limit as x approaches 2, which in that case would be 1. Does anybody other than Kelson see that? Great. Okay. So we're going to take the 2 that's here. We're going to substitute it in for x. 2 times 2 is, minus 2 is. So this is really just looking for h of 2. The limit as x approaches 2 for h of 2. So,
Why isn't it 1?
because,
As 2 approaches, or as x approaches 2, isn't it 1?
yeah, that's what Kelson said.
Oh,
It is 1.
you said 2 times 2 minus 2.
But that's what I'm putting in here.
That's what we were putting in.
And then
eight.
so then it's h of 2, and now we're putting 2 in for the function, and it's approaching 1 at 2. I know it was already 2 because it was already 2. Let's look at the next one here. Okay, so x in this case is 2, and then h of x. So what's h of 2? 1. H of 2 is 1. 1 plus x is, x in this case is 2, so that's,
2 plus 1.
which is 3.
Oh god.
D is the one that's.
So-
That's it.
So A is the weird one. A is the one where
No,
it's just
D is the weird one.
2.
D,
right?
D is a weird one.
So A is just 2, right?
Well, let's take a look here. So let's look at C. So 1 plus 2 is 3, and so now we're evaluating h of 3,
1.
which is 1.
With B 3.
Yeah.
Just
Okay.
ghosts in the room.
Just checking.
I know, we can't use the wooden door stops anymore, but my door is insanely loud when it closes, so I have to keep it propped open. So I'm using a piece of wadded up newspaper. Okay, so back to this. So if I plug in 3 for this one, for part D, it's 3 halves, right? And so between 1 and 2, so we're going to do a little bit of estimating. Between 1 and 2, it's about there.
0.85.
0.75.
Yeah, the answer key says 0.8, 0.75, 0.85, all those are fine. Answer key says 0.8, any of those are fine.
Can we go back over 3A? Because I totally
Sure.
spaced out.
Okay, so I'm putting 2 in for x, so 2 times 2 is,
4.
minus 2 is,
2.
So I'm
that
finding
is
h of
all-
2.
Okay.
which is 1.
So the answer
you're
total
looking
is
for
one.
Yes.
Okay.
Yes! What it approaches.
That makes a lot more sense.
All right. So
Wait, what's with the weird brackets on B?
on B, oh, because it wants you to know that it's like that together. Like it could just have been like another set of plain parentheses. It doesn't need to be fancy brackets like that. All right, let's take a look at the backside. Let's look at number 5 together.
Alright.
Number 5 is the one that I thought you might have trouble with just for E and F, but you might have trouble with more of it because you're going to need to use a ruler for part of it. I know! Tools of measurement.
I don't even understand the question.
I haven't asked one yet.
No, label the parts of the graph.
Okay, we'll get to that. We're getting there, dude. All right, so first thing you want to do is measure how long h is here. And in this case, h just happens to be exactly not an inch. That's this big one down here.
Oh, centimeter.
Centimeter. Not half an inch either, man. Yeah, but we're not, so it's a centimeter, okay? Now, it wants us to find 2 plus h. Here's 2. Then 2 plus h, I'm going to take my handy dandy tool here.
This requires an actual ruler.
Yeah, it requires an actual ruler. So 2 plus h is right there. Because h is 1 centimeter, here's 2. I'm going 1 centimeter past 2, that's 2 plus h.
So do we label it on like this paper?
Yeah, that'd be fine.
Okay. Oh, time to get my planner.
I know, your planner has a ruler on it that measures in centimeters. Or it should, if it has the thingy thing in the
I
middle.
don't know if it does.
Wait, hold up.
Yeah,
What's F of
Oh
2?
boy.
No, it does.
we're getting there, man.
I got lost again.
Oh god.
I'm sorry. I'm
It's
like
okay,
totally
it's okay.
spaced out.
So-
we measured for 1.
1 centimeter, so that's what h is.
Uh-huh.
This is 2. So 2 plus h is 2 plus 1 centimeter.
Oh, okay.
Which is
Each
right
the
there.
1 centimeter. Okay.
Right, right, right. So 2
Oh.
plus 1 centimeter is there.
Okay.
There.
But-
Okay.
So A is just 3?
No, it's not 3 because
Oh, you
it's
just
slightly
label
less than
it.
3.
Okay, so
Yes.
you're- Oh, that makes, okay.
Harvey Robertson,
It's 2
please
units
report
plus
to the
1
office.
Can
And
I borrow
software,
yours?
time to get your pictures taken, so
Uh,
please hand in to
Actually,
the
no.
bar,
In the
gym,
drawer over by
Thank
Tori,
you.
there's a drawer that has a label on it that says rulers, and that's where you will find a ruler. Okay, just because I need to use this one for this. So f of 2. So here's... meh.
Oh, so it's like 0.7.
Well, and we're just labeling, so I'm just even going to go up and over and then just call this part right here f of 2. Because it specifically says to label in the instructions.
I don't like that.
That's okay. You don't have to.
It's weird.
What is the point in this?
When you write a
Exactly.
calculus book, you can have it do something different.
Wait, so then on this line, after that,
Okay, so hold on. Pause. Let's just, everybody pause. I don't want to explain something where only like 3 people are listening. Okay.
The F of 2 pictures,
We're getting there, man.
we're good.
It's not this spot.
it's
It's
like really, really close to it.
okay. No, we're getting there. All right. Let me explain what I just did so that everybody understands the last part, so they can understand the next part. All right. So f of 2 is the value of the function at 2. That means the y value of the function at 2. So here's 2. I just kind of drew my line up and found where it intersects the function and then went over. So this y value right here is the y value of the function at 2. So it would be like, I don't know, 0.9 or something like that. But you don't have to actually put the number down because the question says label. Okay, so we're labeling the graph. Now, here's 2 plus h. For part C, we want to evaluate f of 2 plus h. So I'm going to draw a line straight up, intersecting with the graph. And that's going to be when I draw over the y value of f of 2 plus h. So I'm just going to draw this over now. And so this right here, that there is f of 2 plus h.
Mr. Susan, you're in the building, could you please report to room 11? Mr.
I haven't
Susan?
gone to a math convention in a long time. I think the last one I went to was 2010. And the free stuff they gave out there wasn't very good.
Man.
The next one, is it going to be like a shape?
So it's not going to be shape,
No.
okay?
Yeah.
Yeah, so like
Like with the line.
the difference between these two, that right there, that's f of 2 plus h
Oh, I didn't-
minus f of 2. So
I
it's
thought
the
it was like the weird looking shape.
no, it's the difference between these two y values, which in this case looks like it would be, I don't know, a little less than 1, but you're not asked to find the number for it, you're asked to represent it. So that's d. I know. I know. I know.
Oh boy.
E.
It's okay. I know. All right.
It's okay, I know.
So for E, Okay, it's f of 2 plus h minus f of 2 over 2 plus h minus 2. What this really is, so these f values are really y values, so it's y minus y over x minus x.
So this is that little tiny bracket between the.
It's the slope of the line secant to these 2 points.
So they just go through those 2
I'm
points.
just going to label that line 1, and I'm just going to say it's slope of line 1.
You say M of one.
Sure,
Oh my god.
if you're into the whole brevity thing. Okay, now the next one requires you to measure a centimeter again.
Dang.
I know. So, however, because this time it's 2 minus h,
Wait, did you just put a 1?
what do you mean?
Line.
Oh yeah, I called this line 1, and then I called this slope of line 1, just so that my things are labeled. So I'm going to go a centimeter below 2, which is here. Go up to here. So this is 2 minus h. This is f of 2 minus h. So y minus y, x minus x is the slope of this line secant. So I'm going to call this one line 2. Oh my gosh. Give me a second, let me finish writing, and I'll try to explain it all. Ah! Stop.
I have no idea what just happened.
My screensaver turned on.
No, not that.
Oh, okay. Go away. All right.
I
So
think
let
I
me-
know what's happening.
Let me. Good. That's 1. All right. Just 11 more, and I'm good. Okay. So for each of these pieces here, so 2 plus h
Okay.
here. Yeah, I got that. 2 minus h. F of 2. F of 2 plus h. Right. Okay. The difference between these two is f of 2 plus h minus f of 2. So I marked it there. Just going to do a little thing just to show the difference between the two. Now, for E and F, the hard parts. This is 2 plus h, or f of 2 plus h minus f of 2, so it's y minus y over x minus x, which is the way that we write slope, right? And it's the slope of the line from here to here, from 2 to 2 plus h. It's the slope of this line right here. So I drew in that line, I labeled it line 1, and then here I said it's the slope of line 1. This line right here. So from f of 2 to f of 2 plus h. It's the slope of that line. And that's called a secant line because it touches 2 points on the curve. Kind of, sort of. Secant kind of being like second. Secant. Okay. Now for this other one, this was 2 minus h minus f of 2, so I went back by h. And that's here on the graph. And here's 2. And here's f of 2, here's f of 2 minus h. Y minus y over x minus x means I'm drawing this secant line here. I labeled it 2, and that's the slope of line 2. Any better? Okay.
That ruler is calling me a bad word.
I won't be able to label it.
You won't be able to do what?
Label it.
Well, 7 doesn't use any of that. 7 uses what we were doing in our notes.
Thank the Lord.
So let's look at 7 here. So 7, pay attention, 7 specifically says figure 14, which is this one down here. Not that one. Figure 13 is for 6. 7 is for figure 14. Now this is where the left and right hand limits come in. So 7 and 8 both use figure 14. So first, yeah, I know. The limit as x approaches 1 from the right hand side. So this is just like your notes. Don't be afraid. 2. Yes. Thank you. And then part B, the limit as x approaches 1 from the left hand side. Negative 1.
Wait,
Whoa.
Right.
Okay.
2,
So it's the limit as the function approaches 1 from the right hand side. So here's your right hand. We're approaching 1. So what value is the function approaching? 2, right? Okay. So your answer to 7a is 2. Now the next part is as it's approaching 1 from the left hand side. This one. So what value is the function approaching?
Wait.
Sorry? What did you say? Hey, Kelson?
On D, there's no like gap, so for 4, so it's just the same for all 3 of them, right? Oh my
So anyway, now for part C, it's the general limit, so both sides.
So I'm,
Negative
Okay. Next one, 3 from the right is 2, 3 from the left is 2, and 3
Oh.
in general is 2.
2. Negative 5.
Yeah. They're all 2. Because the reason they're all 2-faced.
okay, no.
It says negative 2. Oh wait, I'm looking at the wrong one.
So was I, Kelsey. I was with you.
I was looking at the wrong one the whole time. Alright. Well,
So in general, it's approaching
7C.
Oh.
Wow. I feel like a dummy.
Now, the last one. That approaches negative 1. So approaches negative 1 from the right. What y value is the function approaching? Okay. As it approaches negative 1 from the left, what value is the function approaching?
Yeah.
Negative 1.
2.
There you go.
Yeah.
Then the general limit. Yes. Yes. This is why I didn't cover right and left hand limits until today.
So,
I would
there's
be
no
confused.
plus or minus now in general, so it depends on both sides.
And if the left and right hand are approaching 2 different values, the general limit does not exist. Okay? But here, as the function approaches negative 1, what y value is it approaching? And the approaching negative 1 from the left is y value is approaching. So, a left or right hand limit can exist where there is no general.
Why did they even put number 8 in the book? Why?
Yeah, it's all one.
It's all one.
Is it? Thank you.
Yes.
Okay.
It's
See, my evil plan, Kelson, was I would go over the harder of these 2 with you guys, and then let you guys do the easier of these 2. Does it freak you out that they're all the same answer?
it just seems
Why?
preposterous.
Preposterous, okay.
Seems like a waste.
Yes.
I know you
It's a
just
waste.
explained 7F, but now I.
It's fine, it's fine. So, 7F. As we're approaching 3 from both sides, so if there's no plus or minus, it's general limit,
Yeah.
you take both directions at once.
So because they're both 2 and 3, but you said one general is 2.
I got 1.8. 3 is the x value.
I just
We're wondering
Oh,
what y
okay.
value is approaching.
Okay, whatever y. Okay.
Mm-hmm.
I'm gonna put it at
Mhm.
1.
So really, the hard one on this assignment is 6. But I did 5, which is eerily similar. Okay, I mean, I can't make you do anything, man. So, but on the front side, we went over question 1, question 2 is just like it. We went over question 3, question 4 is just like it. Okay? And then on the back side, we went over question 5, question 6 is really similar. We went over 7, 8 is really similar. So we've gone over, yeah, we've gone over half the assignment now. Okay? You guys can work together, alone, very much, back on. Yes? What about the assignment?
For GX, it's like barely below 1.
Right, so make an estimate, like say,
2.8.
Oh, I thought it was at 1.
Oh.
for 2A, can we look?
I say it's at 1.
Can we just say it's at 1?
No, because I think, if I remember correctly, 2A is really below 1.
I put 1.7.
So 2A, G of X, 2. Yeah, it's below 1. So like 0.9 or 0.8.
Approaching
Okay.
1.
You'll be okay.
And then you, what?
Okay, no, you're, yes. Upsetness, that's okay. Anger. Frustration.
I'm not as
So,
frustration.
to return this paper in with our.
Yes, please. In fact, if you staple them, that would be awesome.
Yeah.
Oh wait, yeah, they're adding 1 point.
Okay.
Okay, so as of that, is 1,
So
or
2 is 0.9.
0.8 times 1.
Why not 1?
Oh,
Did you 2 is about like 0.8? I got point.
oh, you still use 2 because I was.
Good point.
that sounds.
Okay.
I'm glad we're not doing it quiz today.
Me too.
Same. What, alright,
Not
less than
too
6.
tired, Colleen.
Wait, what did we do for?
What if it's not exactly a
We did
centimeter?
the odds. We did 1, 3, 5, and 7.
How did we do 6,000? Because-
Okay, so,
Oh my god.
so here's a plus h.
Oh,
A
so
minus
we're-
h is gonna be over here, so you get a dot like there, and then over the line between those two.
Okay.
Yeah. What if it's not exactly a centimeter? Look at
Use
this.
it. I thought it was a centimeter when I did it. Use a centimeter.
Okay.
Wait, you can't divide by
Oh,
zero.
it's one.
No, so it's undefined. You cannot divide by zero, so it's undefined. Super lost. Hello. Super lost.
B or 4.
Or b. So, 2.
So we're
2
looking
minus
at
1.
2 feet.
No, I know. Let's do this.
1.25.
Two minus one is h. Okay, what's the second one?
Yeah.
Infinite. Okay, and then what's 1.25 times x, which is 2? So 1.25 times 2. 1.25 times 2. There you go. I don't know. A lot more stuff.
1.75 would be.
Okay, so what's g of 1? Great. What's f of that value? Okay. We're not losing any zero.
Okay, would depends on where the 0 is. Is it 0 over 0 or is it just 0? Then that's 0. 0 is a number. I don't know which one you're doing, and I don't have any information. Let's take a look.
So h of 3 minus h of 3. So then, right, yes.
0 is a number 2.
What's 2 divided by 0? So that's just not right.
Because you can't divide by 0.
Answer.
Undefined. You can't divide by 0. It's mathematically forbidden.
4 B, we can get 3.4.
Would be. That's 3.
Did you use 1.5? Yeah, you used
4. 4B.
Yeah, you might have estimated the value differently, so your answer might come up being different.
Would be cash? So 2 minus 1, so 1. I said 1.5. It's close to 1.5. Maybe.
Okay, so as it approaches 3 from the right hand side, here's 3. What value is the, what y value is the function approaching as you approach 3 from the left? Or, sorry, this way. And as you approach 3 from the left. So write that down. 2. 2. Now, as you approach 1 from the right, or negative 1 from the right. Okay. As you approach negative 1 from the left. If these two numbers don't match, not 0, then it does not exist.
The left-hand limit and right-hand limit are not the same, the limit does not exist.
Right, so you got g of a, now you're gonna move this up, and move over here,
Well,
and then that's g of a plus h.
So do we do this?
Yeah, because you're looking for the value of the function.
Lines are really close together.
All the way there, just like that, like that. You know, you can use your ruler to make this straighter.
I got lines that are pretty close together.
Okay.
How are they going to be like
Say
this
so.
when there's no curve?
now you go to minus h over here. Right, and then line connecting those two. One second.
So on this one, it wouldn't be like a line like this because.
Juniors, please report for
Right,
school
the
teachers.
two lines might
And
gonna be
then
kind of
line up
close.
Yeah, they might
along the stage on the far side of, not along the stage, on the far side of the gym floor. Thank you.
Other line, so we're saying h over here.
Mr. Taft, I'm gonna go through the pictures.
Okay. These two. So they might end up looking really similar.
I don't know where the lines go.
Okay, so for a plus h minus g of a, that's this line connecting these two points. And then you have to find a minus h, which is over here somewhere. And then that'll be the line connecting those two.
I know.
Well, this was a plus h, what would be minus h? Over here,
Cash.
you connected these two, but
This is not so bad.
you gotta show me where a minus h is, so let's show me exactly where a minus h is.
It's short, my dad's
Okay, over here. So right, mark that a minus h. Up to the function.
Oh, yeah,
Up to the function.
Got it, got it.
Function right there. This is the function. Go up to the function.
And there's pictures.
And then go over. Okay, now if you connect these 2 points, the slope of that line is that. This point and that point. No. This point, a minus h from where it intersects the function. And connect those two to the slope of that line. Now it's gonna be this sort of looks like close to your other line.
The lines are almost.
Yeah.
Yeah, the 2 lines on 6 are gonna be really similar.
But this one is gonna be what? I can't remember what it is.
No, those are.
Multiply the three and add three, or add three, four.
Okay, good for you. Now, would you have been able to finish if Kelson hadn't said out loud all of the answers to 8?
Yeah. All the answers,
Well, I
I just
don't
have
know
one
what
number.